This brings us to the end of chapter 4, which is the combined gas law. So, same idea as the other two examples, the other two videos. Now we're going to basically have all the variables, pressure, volume, and temperature. So given those initial conditions, be able to solve for a final pressure, volume, or temperature. And then state the values associated with standard temperature and pressure, STP for gases. I'll talk about that in an example. Okay, so here we go. So we've had Charles' law and Boyle's law. So for Charles' law, if you remember, it said that volume, right, is proportional to temperature. Okay, so that was Charles' law. And then Boyle's law said volume is proportional to 1 over the pressure. Okay, so if you combine those two proportionalities, what you get then, right, is the following. Volume is proportional to temperature times 1 over pressure. Okay, and we can do that because mathematically the same quantity, volume, is proportional to the product of temperature and 1 over pressure. Okay, so here's what we have now. So if we insert a proportionality constant, similar to the other examples, we get volume is equal to some proportionality constant K times T over P. All right, so I'm going to rearrange this equation. All right, so I'm basically going to get K by itself. So I'm going to bring P up, bring T down, if that makes sense. If not, it'll make sense in a second. I get V times P divided by T is equal to K. Okay, that's what I get from rearranging this equation. And so what this is saying, for a fixed quantity of gas, the ratio of PV divided by T is a constant, or I wrote VP, but let me just change it so it's consistent to avoid any confusion. This is PV. It doesn't matter, but just so it matches the notes in the top right here. Okay, so for a fixed quantity of gas, the ratio of PV divided by T is a constant. Okay, and this just tells you right here, standard temperature and pressure, STP for gases. These are just conditions, 0 degrees Celsius and 1 bar or 1 atmosphere. And we'll use that for some example problems later. But from this, right, again, using subscripts 1 and 2 for initial and final variables, we get V1 P1 over T1 is equal to V2 P2 over T2. And I did the same thing again. My notes are different than what we're seeing here. So I'll just write it this way. P1 V1, just so it's the same. P2 V2. Again, it doesn't matter. Okay, but just so it matches the rest of what's on this slide. Okay, so we're going to use that now. This is the combined gas law to solve problems. All right, so let's do an example together. Okay, a sample of krypton gas occupies a volume of 6.68 liters at 64 degrees Celsius and 361 torr. If the volume of the gas sample is increased to 8.99 liters, while the temperature is increased to 114 degrees Celsius, what will be the resulting gas pressure in torr? Okay, so we've got a little bit of everything going on here. So let's write down our combined gas law equation. P1 V1 over T1 is equal to P2 V2 over T2. And let's write down what we have. T2. Okay. So it has an initial volume of 6.69 liters, 6.68 liters, excuse me, liters. I think I said 9. At 64 degrees Celsius and 361 torr as our P1, okay? So these are our initial conditions. And if the volume of the gas is increased to 8.99 liters, so 8.99 liters, while the temperature is increased to 114 degrees Celsius, what will be the resulting gas pressure and torr? So I don't know P2. Okay, so this is all of our variables over here. Okay, now we're going to use this equation to get the pressure in torr. So I want to get the variable P2 by itself. Before I do that though, remember, when we're solving problems that involve temperature in ideal gases, we want to convert the temperatures to Kelvin. So we're going to do that by adding 273. And I actually don't have this written down in my notes, so bear with me while I put this in my calculator. So 64 plus 273 gets 337 Kelvin. Let me just do that again. 64 plus 273, 337 Kelvin. And then 114 plus 273, I get 387 Kelvin. Okay. So now let's rearrange this equation to get the variable P2 by itself. So I'm just going to rewrite the equation here, similar to what we've been doing, just so you could see how I'm doing this. And what I'm going to do is that cross multiplication, where I'm going to bring V2, whoa, got a dotted line there for some reason. That's interesting. Get rid of him, maybe? No? Okay. Never mind. V2 is going to go down. T1 is going to go up, or T2 is going to go up. So what I'm left with after that is T2 times P1 times V1 over T1 times V2 is equal to P2. That dotted line mysteriously went away. So that's what I did there. Okay, so let's put all this in our calculator and see. Well, first let's put the variables in there before we put it in our calculator. So T2, 387 Kelvin times P1, 361 torr, times V1, which is 6.68 liters, over T1, which is 337 Kelvin, times V2, which is 8.99 liters. And I am running out of room, but let me put this in my calculator and see the answer we get. So 387 Kelvin times 361 torr times 6.68 liters divided by 337 Kelvin divided by 8.99 liters. I get a pressure of 308 torr for P2. Let me just put that in my calculator one more time. It's always a good habit to do that. So 386 times 361 times 6.68 divided by 337 divided by 8.99. And that's what I get, 308 torr. And notice all the units canceled here. Kelvin canceled with Kelvin, liters with liters. I was left with the units of pressure, which is torr. So I know that I did this problem correctly. Okay, so that's an example of using the combined gas law. Do I have one more example? I do. So at STP, a gas has a volume of 2.23 liters. When the pressure is increased to 1.04 atmospheres, the gas has a new volume of 1.89 liters. What is the final temperature? So why don't you pause the video and try to do this problem on your own. Okay, so assuming that you did it on your own, let's do it together now. I'm going to go faster this time. I don't have any of these written in my notes, so I'm doing this along with you. Really? I don't know why. I'm missing part of my notes here. So again, I'm writing down my equation, and then I'm writing down my variables. I think this is always a good habit to get into, so you could just visualize what you have, what you don't have. So at STP, well, what was STP? Remember, I said for STP, if you go back, okay, STP for gases is T is 0 degrees Celsius and 1 atmosphere is the pressure, okay? So that means P1 is 1 atmosphere, okay? The volume is 2.23 liters. Temperature is 0 degrees Celsius, which I'm just going to convert to Kelvin. 273, okay? The pressure is increased to 1.05 atmospheres, not a whole lot. And it has a new volume of 1.89 liters. What is the temperature? Oh, whoops. Hold on. There we go. Okay. Sorry, I hit move ahead on the slide. Okay. So I'm going to write the equation again, rearrange. This one's a little trickier, okay? So there's a few ways to do it, but I'm just going to write P1 V1 over T1 is equal to P2 V2 over T2. Same idea. Let's just move T2 out of there. So I get T2 P1 V1 over T1 is equal to P2 V2. And then what I'm going to do is move these guys. So I get T2 is equal to P2 V2 T1 over P1 V1. Okay, and I did that fairly quickly, all right? But again, you should be going through this, solving for each variable and getting practice doing this. And if you have questions, reach out to me, okay? Just for sake of time in the video, just moving a little quicker now, okay? So, and go back and pause it and kind of rewatch to see how I got there. Just cross multiplying really. Okay, so let's put everything in our calculator. So this is equal to 1 atmosphere. No. Sorry. 1.05 atmospheres. Okay, that's P2. 1.89 liters. Oh, I'm running out of room. Oh no. Okay, times T2, which is, or T1, 273. Sorry, this is messy. Over 2.23 liters, 1 atmosphere. Okay, so let's put all that into our calculator and let's see what we get. Okay, 273 times 1.05 times 1.89 divided by 2.23. Okay, so I get T2 equals 243 Kelvin. And I hope you got that answer as well. Let's just check it one more time. 273 times 1.05 times 1.89 divided by 2.23, and that's what I get. Okay, so that's it for this chapter on gases. That's the combined gas law. Make sure to do all the example problems in the homework so that you'll be ready for the quizzes and the tests. Let me know if you have any questions, and I'll see you in chapter 5.